So moving into drinking water disinfection. So how is water disinfected? We're going to start off with just recapping that before we do disinfection, we have to do the clarification steps of coagulation and flocculation, sedimentation and filtration, and then we further purify the water by doing disinfection. Disinfection, here it is, it's way down here. It's after filtration. Intake, clarification steps, then disinfection. After disinfection, it's ready for storage and distribution. So there are a variety of options for disinfection, but let's first look at what disinfection means. Dis means the removal of the infection capabilities of the water. It is possible that pathogens could have been small enough to have made it through our filters. Okay, it's possible that pathogens could have broke through our sedimentation and filtration process. So we disinfect our water, and there are several options. The disinfection is removing the pathogenic potential of the water, inactivating potential pathogens. The options that are most common are chlorine gas, sodium hypochlorite, also known as bleach, ozonation, ultraviolet light or UV, or some combination of methods. Disinfection is not sterilization. Sterilization would tell you that you have completely destroyed or eliminated all living organisms. And that can be accomplished using something like an autoclave with high heat and pressure. That's not feasible or practical for a water plant. So we are disinfecting the water. We are not sterilizing it. Now, chlorination is the most common method used in the United States and probably around the world. When chlorine dissolves in water, so when you mix chlorine with water, it will form these disinfecting agents. And these agents can penetrate cells and kill them by disrupting their enzymatic activity. And the two agents that it forms, along with some disinfection byproducts, the two agents that it forms that can kill and disrupt enzymatic activity are hypochlorous acid as well as hypochlorite ions. See the H in hypochlorous acid? So H is associated with acidity. Remember, hydrochloric acid has a formula of HCl. Hydrofluoric acid has a formula of HF. H in compounds, higher hydrogen ion concentrations favor lower pH. So lower pH favors the production of more hypochlorous acid, whereas higher pH water favors the production of hypochlorite ions. Think of like hydroxyl groups have OHs. Acids have H+. So low pH, acidity, lots of hydrogen ions. Higher pH, less hydrogen ions, more hydroxyl groups, more OHs. So you could remember this: hypochlorous acid, low pH, hypochlorite ions, higher pH waters favor more production of it. Now, chlorine indiscriminately reacts with the dissolved substances in the water. It's not seeking out which pathogens to kill and to leave certain things away. So chlorine will be used up or will be bound with both organic and sometimes inorganic compounds in the water. The chlorine demand is how much chlorine is needed. So chlorine demand is the difference between the amount of chlorine that's added, the total chlorine, and the residual chlorine after a certain amount of time. So that's the demand. We have the total chlorine here and then minus how much is left, and then we would know what the true demand is. So chlorine demand is the amount of chlorine needed to oxidize all the dissolved stuff in the water. Now, chlorine indiscriminately reacts with a lot of stuff in the water, and sometimes it will also form another compound called chloramines, and this forms when chlorine interacts with any dissolved ammonia in the water. And these chloramines, they can also disinfect. So it's important for us when we think about chlorinating water or doing disinfection with chlorine to know that a lot of the chlorine is actually used up on non-living substances. So if you've got a lot of unclear water and you haven't really filtered a lot of stuff out or done any sedimentation prior, you're going to need a lot of chlorine because a lot of the chlorine gets used up. And we have to have enough chlorine to prevent microbes escaping disinfection. So it's important to remember. So to prevent the escape of disinfection by those microbes, a process called breakpoint chlorination is sometimes used. We'll discuss that more in a future video. Upon watching this video, you should be able to do a quick review here. What's the difference between disinfection and sterilization? What are the common methods used? All of this. So I'm going to put this slide up here and then we're going to go over